Testing. What's up? I'm Jacob Litzo, your Elixir Mentor. Welcome to another exciting episode of the Elixir Mentor Podcast. This is where we discuss everything related to Elixir, from interviews with enthusiasts, pioneers in the community, to innovative projects and libraries shaping Elixir's future. So let's get started. Today, I'm excited to welcome Dave Lucia. I knew I was going to...
Lucia.
I always butcher last names when I have it in my head a different way. Well, he's the CTO and co-founder at TV Labs. He's an active member of the Elixir community. He speaks at events like Codebeam and the Elixir Conf, and he also shares his insights on his blog at davelucia.com. So check that out. I have that in the description below as well. And Dave, it's great to have you here, and thank you so much for joining me. You want to go ahead and just give a brief introduction of yourself?
Well, you did a great job. Thank you for having me here on the live stream. I'm Dave Lucia. I've been doing Elixir professionally in production since 2016, starting at the outline. Still love the language. This is my fourth company that I'm working at using Elixir as the primary technology, and still think it's a great fit and more excited than ever about it as tech. What else about me? I don't know. I think that's a good start.
All right, perfect. So you've been in the Elixir world for about 8 years, and you have quite an impressive resume, but you're currently CTO and co-founder at TV Labs. Do you want to talk a little bit about what you're doing over there right now?
Yeah, absolutely. So we're pretty early on in our journey at TV Labs, but what we're setting out to do is to help media companies who build smart TV apps a better way to test their apps on real physical hardware. There's a problem in the space where there's many different types of devices, and you might be thinking like, oh, okay, well, there's new TVs out every year, and so there's the problem with testing new LG televisions and new Samsungs. And the problem is actually the older ones. So there's, quite a bit of issue with TVs that are 8 years old that are still quite prevalent and in production. And the emulator tools and simulator tools that the manufacturers give you aren't quite what it really is like to work on a real television. So what we do is we take TVs, we built our own hardware, and we put the TV in a box. We have cameras pointed at it. We have compute that sits next to each TV. And then we allow you to interact with the TV from the comfort of your web browser as if it's right in front of you, including things like connecting to the TV, uploading builds to it, using the debugging tooling, all through the comfort of your command line interface. And then we layer automation on top of that. So we allow you to write through a no-code platform that we're building, scripts and tests and automations to be able to test different workflows, find regressions, find UI bugs, and all sorts of things. From every single pull request that you make, you can test against real television. So a lot of really interesting problems in there with video streaming and hardware, firmware, distributed systems. Right now, I'm deep into debugging a deadlock bug in the core of our video streaming framework. So really exciting stuff. Oh, and then I forgot about machine learning and all that other stuff as well. So a small team working on a lot of interesting problems in the TV space.
Interesting. So do you just have a warehouse of old TVs?
Pretty much, yeah.
Like a TV farm?
We call it our compute cluster, but we have basically a big room. Every single room, there's a box. The box has our custom-made printed circuit boards inside of it. You can see the TV Labs logo right there.
Okay.
All of the TVs are connected to their own uplink to the internet. They've got isolated power. We also have like a farm of set-top boxes like Apple TVs and Roku's and Fire TVs, gaming consoles, things like that. So if you step into our our compute cluster. It's an interesting place because we also have a pick and place machine that takes like the silicon wafers and places all the components on it. And then we have like a reflow oven to bake them. We have a 3D printer going. It's a pretty fun place to visit and check out.
Wow, that's awesome. That sounds really cool. Like definitely over my head, but it'd be pretty cool.
Was over my head too, but slowly.
No, I love that. So what are you using? Where are you using Elixir between all your cards and the user interface then in the web browser?
Great question. We run Elixir in two main places. So we have the televisions themselves. We have a basically a little NUC computer, basically pre-built computer that has GPUs and CPUs on it. And on there, we run Elixir. And what that does is that does coordination, talking to the television, being able to execute scripts. We actually execute Lua on our Elixir process that's running next to the television so that you can automate interacting with the television. What else do we do on there? It monitors the health of the TV, connections, also because we're emitting IR and other protocols with the television. We interact at a binary level to send information to the firmware so it can emit IR signals to the television. We machine learn on the boxes, so you're able to run text detection, different models for detecting different things on the screen, all right next to the television. And that's all happening in Elixir, but it's communicating up to our web service that's also in Elixir. And what's really cool about this is we can communicate over Phoenix PubSub. From your web browser, you click on a button in live view, and then it could Phoenix PubSub a message all the way down to our edge compute and trigger some process. So we kind of have like an end-to-end Elixir deployment. It's not distributed Elixir at the edge level, but it is distributed Elixir in the cloud.
Nice. Okay. No, that's cool. That's really awesome. So where are you located? Where is your compute cluster headquarters?
We are headquartered in New York City.
Okay. Awesome. That is
I'm
cool.
in Long Island, which is east of New York City.
Okay. So if I'm ever out on the East Coast, do I get to have a tour?
Sure. Yeah. Well, there might be a conference announcement coming for later this year. So that could be a reason to come visit.
That would be awesome.
Stay tuned on that.
I will. I'm on the edge of my seat. So I know. Well, when we were chatting, when I asked you to come on my podcast, you gave me a list of topics, and I was like, well, they all sound good. And so I think what we can do is, like, I'm not familiar with Rustler, but I know what it is and like why it's used. And I would love to talk about Rustler a little bit, like where you have used it in production and like where those benefits come in. And I know like using Rust and Elixir, they work together great, right? Like a lot of companies like Discord and like other ones out there, they'll use Rust for like high computing power, where like maybe cryptography and like other things that are like very heavy process oriented. But how does Rustler like relate with the Elixir development?
So I think you described it really well. Rustler really fits in when you have either some library that's low level that you want to interact with that you can't do natively with Elixir. So maybe it's some like operating system level service or some crypto library, as you said. Another reason is performance. So I'm doing something and it's super slow in Elixir and I can't really eke out the performance. This is a good case for NIFs in general, which are native implemented functions. And the main way to write a NIF, or the original way I should say, is in C. So the Erlang, I guess would be the Erlang runtime system, has a C API, a bunch of headers called enif, and those are the bindings that you can use to write a shared library that gets dynamically loaded into the beam, and then you can call functions as if they were just regular Elixir functions, but interacting with native code. This is something that Elixir NX is doing. So the various backends that Elixir NX has, like EXLA, that's actually ultimately putting the code that you write in Elixir NX and shipping it onto, would be the GPU, but through a NIF. Another example of this is Floki, the HTML parsing library. You can swap out its backend and use a Rust backend to make it go a bit faster. I think the best example that I heard when I was first learning about NIFs was Discord's usage, as you said, where they had massive rooms with like tens of thousands of people in it, and they needed to see like who was active in the room and just basically sort the list. Like if someone went inactive, go to the bottom. And this just became super slow in Elixir and ETS, and they like tries to squeeze out all the performance they could. And so they rewrote it as a NIF. And all of a sudden, 100 times faster. I don't know, making up that number, but great blog post on the Discord blog from like 5 or 6 years ago. So Rustler in particular is a way to write NIFs in Rust. And this is particularly interesting because there's a lot of excitement around Rust in general in the programming community. There's a lot of interesting tech that is written in Rust. And the interface for writing Rust code and then interfacing with Elixir is really nice because you can serialize and deserialize Elixir native types, either return them from Rust or pass like a struct and receive it in Rust as a Rust struct or Rust enum. And it makes it really, really joyful to work with. There's also Ziggler, which is kind of like the same thing, writing NIFs in Zig by Isaac Yonemoto, which is also a really interesting piece of tech that uses kind of a different approach for how you interface with it, but also really interesting. So I kind of took that and ran with it. Maybe if there's another more specific question about
no,
Rustler,
I think that was good. Do you have any, like, have you ever used Rustler in production, or have you just dabbled with it?
I'm using it in production right now at TV Labs. I got started with Rustler back in 2019, where we were at early days at SimpleBet, which was a sports betting company that I was at for many years. And we were trying to do what are called micro markets. So imagine you're watching a baseball game and you want to be able to bet on every single pitch in a game. We were trying to set the odds in between every pitch so that if you said like the next pitch is going to be a strike, that we would know the odds of whether it's going to be a strike, a ball, a hit, if it's going to be a strikeout, whatever. We naively tried to implement a machine learning framework in Rust and run it as a NIF inside of Elixir, which was an idea by the CTO of SimpleBet at the time. And I didn't know anything about machine learning at the time. And so I was like, well, Rust is fast, so of course we want to do it this way. And there's a whole list of reasons why you should not do this. I actually gave a talk about this at CodeBeam SF in 2020 called Rustling Up Predictive Sports Betting Models on the Beam. But due to, I think, the social complexity of building a startup and a lot of people and a lot of cooks in the kitchen, we kind of ended up in this place where we were trying to implement this machine learning framework in Rust. And it was a horrible idea. Don't do that. Don't try and implement k-means clustering yourself in Rust. There's probably a better way. And what we learned was there was a better way, and what we were doing was absolutely ridiculous. But that was the introduction to me for Rust. And it was very fun to be able to kind of just dive into this problem and learn very quickly that we were down the wrong path. But we did put it into production. It did power our early product for probably about like 6 to 9 months before we went back to the drawing board and we're like, this is not going to scale. This is not going to work. We need to rethink this thing. So that was my first usage of Rustler. Kind of paused that for a while. I had made some contributions to Rustler around returning better errors when things didn't serialize correctly. Didn't use it for probably 4 or 5 years until TV Labs. And at TV Labs, we have kind of quite a bit of C code that we need to interface with. Some of it is firmware level stuff. Other it is our video pipelines. And so we very recently moved our video pipeline into our Elixir service as a Rust NIF. And this has been, it was motivated by stability. We wanted to be able to have really tight control over the starting and stopping of our video pipelines, because we're taking camera feeds and we're broadcasting them over WebRTC to your web browser, and starting and stopping the cameras, grabbing certain information from the video pipeline, all these things. We were previously doing it in Python and communicating over gRPC from Elixir to Python. And basically we had two stateful things that were trying to control each other, which is a recipe for really nasty bugs that are very hard to control. So we put the control to Elixir and said, okay, instead of using a service level interface, we're going to use a binary level interface, and we're going to remove that network hop, but also build a much tighter integration with the code. And this was a massive stability increase for us. So integrating this into Elixir via Rustler has a lot of challenges, but has been really fun and really rewarding to see the stability improvements from it.
That's really cool. So like you did it from a stability standpoint, when would you know to use it for like a performance standpoint? Do you know when you're pushing Elixir's processing ability to its limits, or like how would you know that you need to optimize something?
That's a hard question to ask because it's very contextually dependent. I would say most of the time you don't need it. I think you're going to notice that you're going to need to do something else if you've exhausted all other options.
Yeah.
So I don't know, maybe it's that you have a lot of data and you need to process it really quickly, or that low level library. I think the obvious one when you need, to interact with the NIF is if you're interfacing with some library that you just can't possibly replicate in Elixir because it's too big or too complicated or too risky. That's a good use case for NIF. But even then, I think your first choice should not be a NIF. Your first choice should be wrap it in a service and communicate over that way, or wrap it in a port, which allows you to like basically shell out to another program from Elixir. These are all safer options because NIFs have a big risk with them, which is that if they crash, so if they cause like a seg fault, I don't know if we have any C programmers on the live stream, but remember, dereferencing a null pointer, seg fault, oh no, that takes down the whole Beam VM. And so when you're writing a NIF, you run this risk of, if I write bad code, if I do something in unsafe NIF or in an unsafe block in Rust, or more likely, my Rust code is interfacing with some C code that doesn't know anything about safety, memory safety, the whole thing can go down. Memory leaks can happen. There's a whole host of like kind of dangerous stuff. So I think before we talk about when do you know you should use NIFs, I think you should know when you shouldn't use NIFs, and it's use them as a last resort. There's really a lot of dangers that comes with it. You can also mess with the Erlang Beam schedulers. So if you are spending too much time in the NIF and you haven't marked it correctly, there's like all these kind of like fail safes for it. Dirty NIFs are an example of one of the ways that you can fail safe it. The scheduler will just be completely off and it will make your whole system seem unstable and wonky. So those are many reasons not to do it. The reasons to do it are, let's say you have a lot of data and you're searching through this data and you start with a gen server. So you have like a big list of things and you're doing enum.find. That's too slow. Okay, well now we're going to move to a map. And so we do, map.get, a little bit more of an optimized lookup. You're now O of log n instead of O of n. Still slow. Okay, well, let's put it into an ets table because that's optimized in C. So now you do that, you're using match specs, you realize you hate match specs, but it's faster, it is great, and then you hit the limits of that. this is at the point where you're like, okay, if this is too slow for my use case, I've measured this. Maybe that's a case where you want to start using a NIF. Another example of this could be like, I'm parsing HTML documents in Floki, and the native Elixir parser is just like taking multiple seconds, and I need to do this when I render a user page, and it's not acceptable to do this in 3 seconds because the user's going to be waiting for 3 seconds. Mm-hmm. Okay, maybe this is contrived. You could do async assigns or whatever. But you can imagine use cases like this where it's just too slow and you've exhausted all their options. NIF.
Okay. Yeah, that makes sense to me. You kind of scared me from using Rustler. I'm not going to lie.
It's like the first rule of macros. Do not use macros.
I was just going to say Chris's book, Chris McCord's book, for meta programming. Do not use them. But it's such a good book. No, that's awesome. I love that. Do you have any like resources that you like for maybe Elixir developers learning Rust and adopting Rustler into projects if they need it?
Yeah. So the best way to learn Rust, I think, is a pair of 3 things. The Rust programming language book, which is written by Steve Klabnik, who's over at Oxide Computer. Great book. It's free online. It is always kept up to date. I have the hard copy sitting on my shelf over there, but the free copy online actually is the one I actually read. So start there. Read like the first chapter, then download Rustlings, which is a interactive way to learn Rustler. To learn Rust, sorry, not Rustler. So they basically like have like a bunch of examples. You like program up the thing, you run the test, and then it tells you if you did it correctly. And then Rust by example is the third way. The learning journey, Rust is complicated and it's hard to wrap your head around. Those 3 things together, I think, are a great way to get your head around the language.
Awesome. I've always heard. Nice. I've always heard the Rust community though is a very opinionated group.
I haven't really interacted that much with the Rust community, so I've heard that too.
Yeah.
I mean, maybe there's some truth to it. I'm not sure. Rust is like, there's so much software that's written in Rust that's really great. Like ripgrep comes to mind as like the first piece of Rust software I like directly interacted with, and I was like, wow, this is so fast. This is amazing. All these features. I've like systematically been replacing a lot of my command line tools with Rust replacements. And it's not even because it's Rust. It's just because like someone's like, you know what, Dig, like the DNS tool, it's old and kind of clunky. I'm going to rewrite it and make it better. And I'm just going to so happen to do it in Rust. And so there's this newer version called Dog. That's like the output's better. You can get it in like, I think you can get output in JSON or whatever. It's great. And there's so many different examples of tools like this that have been rewritten. A lot of them actually are moving towards Go as well, which is maybe a better language for writing CLIs in some ways. But yeah, the language and the ecosystem are really big and comprehensive. Excuse me, and fun to work with.
Awesome. One of these days, I believe the Discord blog article you were talking about, it actually might have been FlyIO's article with Rustler. And ever since I read that, like how to integrate, I was like, I need an excuse to try it, but I haven't had time or found my excuse to try it out. But one of these days.
Yeah, I mean, I would just do something stupid. Like I gave a talk and I threw in a Rust NIF where it just did like SpongeBob text. So like you give it text and it converts it into, random capitals and lowercase. My friend Todd Residek and I had done that together like many years ago for absolutely no reason other than it was fun. So it's just like, yeah, if you're interested in it, dabble, and maybe you feel more comfortable in it to solve a real problem in the future. Although you probably shouldn't.
Yeah, don't use it, guys, unless you absolutely need it. Unless you're streaming video, right? And that's complicated right. Things where you need C libraries.
That's right.
That's awesome. All right. So you're a CTO, and you've been in like a lot of like leadership positions, I feel like, right? And
Yes.
yeah, so you've managed teams of developers a lot. I think like when I'm on a very small team, it's just like usually me and one other dev, and every once in a while we'll contract out devs. But managing developers on large projects can be a huge pain. So, do you have any advice or like strategies that you find like most effective when you start developing like a team culture and bringing developers onto your teams?
Yes. So there's a lot of ways that you can approach management and many different philosophies. There's also another piece around besides management is culture. So, what are the ways that you want to interact with people at a company? What kind of company do you want to be? What are your values? What is important to you? What are the things that you want, everyone to celebrate and to embrace? What are the things that you don't want them to celebrate and embrace? Um, and so these problems can be like interconnected, especially early on in startups. And this is something that I like, especially my last two companies where they're started from the ground up, that I think a lot about, which is, what are the things that we do every day that become kind of habits and are repeatable that we want to have everyone on the team doing. I'm thinking things like small incremental PRs, being gracious and, communicating your thoughts in written form, and, being thoughtful about, how you communicate ideas, how you prepare for projects, and kind of start from the, customer perspective rather than the engineer perspective. So when I think about teams, I'm kind of thinking about all these things, but um, I guess in terms of management philosophy, my first role as a manager was kind of jumping into the deep end head first. I pretty much overnight went from a architect to a VP of engineering, and went from 0 reports to about 30 reports. And so it was like, okay, this is crazy. What do I do here? And that took a long time to kind of sort out and to kind of figure out like what are the right ways in which we organize people around a product. And something that I learned kind of over the years through making a lot of mistakes is something called Conway's Law. And Conway's Law is this idea that the software architecture of your product tends to mimic the communication structures of your organization. So like the classic example is if you have like 3 teams working on a compiler, you're going to have a 3-phase compiler, because each team is going to want to do their own thing. And so they're going to like replicate different ideas. And so, it's going to have to go for the first team pass, second team pass, third team pass. But as you think about this and try and extrapolate to other types of companies, you might have a team that specializes in machine learning and a team that specializes in building web software. And there's different ways in which you can organize the team by making them cross-functional, so they all sit down next to each other physically or virtually, but they all kind of like interact on a daily basis, and they're high communication, high bandwidth communication. We're talking every day. There can be teams where it's like, we have a machine learning team because we have like 5 different product groups that all focus on like, I don't know, one is like the sales part of the product, and another is like the web portal and logistics, something else. And so we can't afford to have a machine learning engineer on every team, even though we need them. So they become kind of like their own isolated thing. And what ends up happening, depending on these communication structures, is that you end up with either their services or libraries or what have you that form around like how these teams were created. So like the team that has like the embedded machine learning engineer might end up with a different like software architecture than the team that has to like go over to the machine learning team and be like, can I get a model for this? trying to come back to management here. The first thing when I think about in when I'm like building a team at a company is kind of like, what is the desired architecture? Like if I look at our product and I'm trying to think a few steps forward, is like, what are we planning for? Like, where are we trying to go? Like we don't want to plan for everything, but we do want to kind of have like a general sense of what is the thing that we're trying to build here and what is the general shape of it. From there, you kind of, have a general software architecture in mind. For Elixir, maybe it's, just one monolith, and that's great. But as you get bigger and more complex projects, just a single monolith might not be enough. Or before the days of Elixir and X, maybe you need this machine learning service or library that you have to interface with Python or whatever, because that's the technology. So you plan for this, and then you kind of like organize the teams as you grow around this architecture, rather than the other way around, where it just kind of like evolves organically. You could do that too, but you might end up with kind of something that you didn't plan for, didn't desire, and then have to do what's called a reverse Conway maneuver, which is a ridiculous term. And that's where you change the architecture to suit the communication structures and vice versa. So going back to management, I'm thinking about, how do I structure a team? And then as I'm thinking about team building and growing a team, it's really about, for me, how do I create learning opportunities and, opportunities for my team to grow as individuals? Because I think, in my experience, engineers and especially high-performing engineers, are motivated by learning opportunities more than anything else, more than compensation, more than work-life balance, more than really anything else. It's like, if I'm like, oh, I'm going to go use Elixir, like that sounds great. Like I'll take a huge pay cut for that. Or, I get to do machine learning. Oh my God.
Yeah. I remember like the very first startup I was a part of, like, cause I transitioned from kind of electrical mechanical engineering from a factory to software.
Oh, wow.
And I finally, got my foot in the door at a startup, and apparently, I was a fast learner. I was catching on quick, and I got thrown into the fire. After just like a year of being a iOS developer, I got thrown into the fire, and now I was everything. I was managing people, and I was building, 4 different platforms. And it was stressful, but it also motivated me, and like I was getting paid pennies because it was a startup with no money. But you love the responsibility, especially when you're kind of new.
Yeah, it's addicting. It's fun. It's I think it also sets you up for your future and allows you to grow and to become more valuable as a contributor. And I know all this because that's me. That's like kind of what I always wanted. I always, when I was looking for new jobs or whatever, I was always seeking out these like big learning opportunities where I could go from A and grow myself to B. So yeah, I really try and optimize for that, and kind of like hope for, to have all the other things as well. It's great to be able to pay people well and keep them excited and have an awesome, product that everyone's excited about too. But, when you're tweaking things and you're trying to look for, well, I can only grow the team by this much. I try to seek out the people who are really motivated to learn and really excited to be a part of your project, because I think that can be contagious, to have so much passion for what you're doing and to want to grow and to teach the rest of the team you're learning. So, it's an exciting culture to be a part of.
Yeah, I agree. And building a team, especially startup phase, like let's pretend like bootstrapped, you don't have any money. It's incredibly hard to know who you need first of all. And like, do you actually even need to hire anyone yet? And when you start looking for people to join a very bootstrapped team, what kind of engineer are you looking for? Are you looking for someone that's senior level, has all the experience that you need? Or are you more concerned about enthusiasm and like willingness to learn and take some of that, what's the word I'm looking for? Responsibility, just to kind of be self-driven to learn? So
I think I'm willing to do both. Although the thing that I think is important is that you can only risk so much, like especially an early stage startup. And so the thing that is the most valuable resource, besides the capital left in your bank account is time, right? Like we need to be focused on generating value for the business, releasing new things for our customers so that they're happy, so that they want to pay for whatever you're building, so that you can continue to be a business and that you can bring on more people to the team. So time ends up being a very critical resource because everything kind of follows from that. And when I look at, who do I hire first, I really need to hire kind of this experienced person who doesn't need a lot of guidance, who can be given sort of like a mandate, like this is what we need to do. This is like the direction we're heading. And this is like kind of like some guardrails. I need you to run at that problem. I don't need you to consult me for, should I write a for loop or a while loop? We're in Elixir, so that's irrelevant. But the point being is like, I want you to take ownership. And so there really takes someone who has experience, who really knows, and is confident in their abilities, and that I also have trust in them and their abilities to be able to execute on problems with somewhat low touch from a management perspective. But within that, once you have that person, or if you feel that you have enough bandwidth, that's where I think these hungry, let's say junior engineers, people who are earlier in their career, who've demonstrated like, hey, I can solve problems. And one way to gauge this is like, do they have any side projects that are interesting? Do they contribute to open source? Do they blog? Do they do any of these things that are kind of like signals that they're like really geared towards learning and trying new things and taking risks? I love those kinds of people. And I've hired them in prior roles and with great success. Usually these people need just a little bit of guidance and kind of, you step over their toes a little bit. You can help them, get back up and say like, hey, you tried that. Let's keep moving in the right direction. Those people can grow, but can also grow in a way that is aligned with like the type of team that you're trying to build and the type of culture and product and everything else. What I mean to say there is like, you can kind of mold and grow someone who's early in a career kind of with you, whereas someone who's 10, 12 years of experience, like myself, I tend to be very opinionated and I have a lot of ways of doing things. And so
you're stuck in your ways.
Yeah. I mean, I like to think that I'm open-minded, but there's also, certain things I'm like, well, I have a strong opinion about this, loosely held sometimes, not so loosely held other times. And when you go to hire someone who's, more experienced, you kind of have to do this big filter where you're like, is this person compatible with the team that we're trying to build? And, sometimes you don't have the luxury of filtering that out that early, and sometimes you just simply can't know until you work together. But there is kind of like that risk on the hiring a senior engineer side of things, which is this person kind of fundamentally compatible with the culture that we're trying to build and the level of ownership that I'm looking for?
Yeah, I've been on some teams where we've had multiple senior engineers that were very opinionated, and they would fight over the silliest things.
Yep.
Just like how things should be done, right? And you don't always want constant conflict on your teams either. So I tend to agree. Like, obviously, you need your senior levels to make sure everything's being built and architected, in a scalable way. But the nice thing with bringing, more junior devs on is, you mold them to fit your culture and how you want to write code and, release features and, everything along the way.
That's right. Yeah. I said this on another podcast, but like, I really believe it's about taste. Like there's certain things where it might not be wrong or right, but it's just kind of like how you like things to be done, or more maybe a philosophy, or, you could apply this like testing strategies or, release cycles, or even just like how you write code. You kind of want to like curate a taste, and then you want to get everyone on board, which is like, all right, we're going to go eat the same meal together and enjoy it equally. And when you have people who are kind of like fighting at the dinner table over like, we're going to eat spaghetti and meatballs or, a steak, that kind of gets in the way of time, right? So you do need to kind of have that alignment early on at the culture level, because that could really steal that most precious resource, time. So that's why it's very important to me when I'm recruiting people and bring people onto the team, that there's really strong alignment there about how we want to build and to operate as a group.
Do you prefer to have most of your systems in place before you bring other people on your team?
Yes.
Yeah.
Yeah.
You want to have your feature roadmap, probably a good development procedure or process in place as well, like how you do pull requests. When do you take things from development to staging to production, what your QA process is? Do you like to have all that in place before bringing extra engineers on?
I like to have a really stable foundation before I onboard anyone. And this goes for teams. This goes for new projects, really anything. When I think about building something fundamentally new, we just did this for this Rust thing, right? Where we had this Python service. It was well integrated. We've been using it for 9 months, but it didn't work. Rather than just rewriting it on a whim and sorry, my 1-year-old just got home. Rather than rewriting it on a whim and kind of being we're doing this, it's better to take something off to the side, build a foundation, kind of show, don't tell, demonstrate why it's a good fit, let other people participate early on once it has a stable foundation, and then kind of incorporate it into the project. So that's an example of taking a prototype and then incorporating it into a project. But I think it goes for anything really, where if you try to engage with other people too early in the process, you end up having to justify a lot of decisions that maybe actually you didn't have strong opinions about. They're just kind of I had to choose A, B, or C, and I chose B, not for a good reason. And some of those decisions haven't stabilized yet. And so you can end up kind of with having to either justify every decision, like we do, merges to made, get auto deployed to production, as opposed to promote to dev, then staging, then production. Or maybe you don't want to have a production environment at all. A staging and dev environment at all. Maybe you only have production.
Oh my gosh. Do people do that?
We do that.
Really?
Yeah, we do.
Okay.
There's reasons why we should have a staging environment and reasons we shouldn't. We're getting on a different topic here, but actually I was just reading another CTO who deleted their staging and dev environments and only did we release in prod, we use feature flags, we use distributed tracing and other observability tools.
Okay. I'm actually curious, if you don't mind completely shifting our conversation to this.
Oh, let's go. Let's go.
Cool. So it's funny because I'm currently working on, so for hired gun apps, we're kind of creating a new product where we're making more templated websites that are just where we can have set prices on things. Because in the dev world, it's very hard. Everything is it's a proposal. You have to take their feature list and then you take a week, you write a big expensive proposal, and then you scare a lot of people off. So I'm building kind of a website hosting platform all through Elixir, Phoenix, and LiveView, where I'm kind of using Plug to route to my different domains, and then Nginx and certbot and all that good stuff for SSL stuff. But I was trying to think about how I'm going to take, new websites that are going to our production platform. Is there a good way to step it from development to staging to production? So, because in this case, a lot of things after you build the templated website needs to go just straight to production. Mm-hmm. So I'm super curious on your take on that and how, what would be a good way to organize something like that?
So I'm trying to wrap my head around what is the problem.
So I guess right now,
I imagine this is a Squarespace kind of product.
Yeah, but direction? A little more hands off for the client.
Okay.
So that you kind of, I have an onboarding, you kind of figure out what they like from,
Mm-hmm.
templates and decisions and things. And then we write it up, with our shared component library that we have written and like a lot of like shared resources. And then,
Mm-hmm.
we spit out, a static homepage, some live views, and everything's kind of like organized by domain in one project.
Okay. And so you want to be able to have a way to um, evaluate the product for the customer before it goes live, right?
Yes, exactly.
Right. So, I mean, this might be a good case for staging where it's like, okay, we want to have like some place where we can like do crazy content changes and fundamentally change the look and feel of the website. And I think that's a really good case for having like a separate environment where you can make global configuration changes.
Mm-hmm.
Um, the place where it's like test in production, work in production is where the problems that you have or the data or kind of the usage patterns are really hard to replicate in another environment. So for us, like we have physical hardware, right? And it's like a staging environment would mean either we've like built some sort of simulator or like some like kind of stripped down version of the product to put into a staging. Um, and that's a lot of work for us and capital expense. Or we put it into production and we kind of embrace certain practices and tools that allow us to evaluate things in production and try out new features or new hardware, but hide them from customers in various ways or like roll them out incrementally. Maybe we want to turn on a feature flag so that only this organization gets this one feature. You kind of have to architect for it and build it in, and it becomes challenging where it's like I want to make like this like big database change that like might like drastically impact performance. That's where it's like, it'd be nice, a staging environment where I
Mm-hmm.
could copy down the database and do all that. So there's still a good use case for things like that, but there's certain sets of problems where unless you're getting like real usage, you can't really replicate the problems or really get the value out of the staging environment. And so that's where I think testing in production and this kind of like philosophy really comes from is, if you're Discord, you don't really have, a staging environment that has tens of millions or hundreds of millions, whatever, however many millions of users they have.
And it's
Um,
really hard to simulate that too.
yeah. Yeah.
Yeah,
So I'd imagine they do a lot of testing in production with feature flags and all these kinds of things, canary rollouts of,
that
here's
makes
a
sense.
major new feature. Let's roll it out to 5% of Discord servers, see how it performs. And what you want from this is you want to have really good observability tools so that if there is an issue or performance regression or just different behavior from the system, that you can kind of dive in, dissect, ask the system questions, and get back data so that you can kind of get to the root cause of a problem or really understand a performance regression or different usage and be able to isolate that and react to it. Like if you're going to test in production, but you don't have like that insight into the system, you're kind of just flying blind and you're not really getting the value out
Which
of it.
is why I think that concept sounds so scary to a lot of people too, because you don't have the proper tools in place to actually test in production.
That's right. Like if you are operating off of logs and metrics and you don't have distributed tracing tools and like ways to like slice and dice spans in your system, or you don't have Elixir where I can like SSH into a box and use recon trace to like see whenever a very particular function is getting called with a very particular set of arguments and debug things that way.
Mm-hmm.
Um, Without those tools, it is very scary, and you probably shouldn't do it if you don't have those tools in place.
What kind of like observe now I can't say the damn word.
Observability.
Observability tools are you using for, like, I'm guessing you use them through like telemetry, however, like, and what you watch your ecto and database transactions then, and
So we have a lot of different observability tools that we've built into our system. The you can think in the three pillars, which I think is maybe the wrong way to frame it, but you've got logs, metrics, and traces. Logs being like logger.info, metrics being, the number of HTTP requests that happened in the last minute, and traces being, basically a stack trace of I called this function, and then there's, some other function that got called below it, and they each took this time, and this was the attributes that were called with it. We use for logging, we ship our logs to BetterStack, which is a nice platform where you can turn logs into metrics, into time series, and alert on them, and do uptime and things like that. We've played around with Grafana Cloud and kind of find it really hard to work with. And, not as big of a fan of it as I was hoping to be. And for our distributed tracing tooling, we use Honeycomb, which is a great tool that allows you to search through spans and build charts and ask the system questions. Like I was actually asking a question today, which was, when we start a video session with a TV, how long does it take to make a request to get our turn server credentials, which facilitates a WebRTC session? And so I was working on optimizing some of that flow. So I wanted to see, since I released this change, how did the request time for starting a new session, how did the shape of that traffic change? And I can kind of ask this question and slice and dice based on my customers in Europe versus my customers in the US. And I don't have to pre-configure some dashboard in Grafana to know that. I can just ask it on the fly. That's kind of the main advantage of distributed tracing tools, is that they have these facilities. But then we've also built a lot of observability tools ourselves. Very hard word to say.
It's a tongue twister.
So on our in our TVs, there's a lot of hardware and just things that can break and go wrong. And so we have a gen server that runs that we call our health check process. And this is either running different pollers that are checking hey, is the TV online? Am I able to hit the IP? Or, our machine learning service, is this the connection for it up? And with process links and using the telemetry library under the hood, we can respond and see oh, something went down, or we got a bunch of our firmware sent us a bunch of corrupted data. So mark ourselves as unhealthy so that we reject any future sessions and send alert to the team so that we can look into it. So we've built kind of a lot of this tooling ourselves to solve the problem of how do we make our system really reliable? And for that, it's knowing that we have a problem before our customers do.
Mm-hmm. I like that. Because I'm going to have to build all these tools now, because I'm going to have to know if, the websites that I'm hosting are actually working and do regular health checks on them. Because you can't just assume that just because your server's up that everything else is working.
Yeah, it's an interesting problem to solve when you take it from the perspective of the user. And there's also really good tools for doing that. There's this idea of synthetic testing. Synthetic testing is where you write basically bots that kind of interact with your product as if they're a real user. And then you pair that with observability tooling where if they trigger a flow where, I don't know, they raise an exception because they click a button that wasn't well tested, and that raises that this synthetic monitoring catches the problem before you do. Andrew Stewart, who I believe has been on the live stream, introduced me to a really, really cool product that I'm forgetting the name of. So I'll have to send you that after. But you can write a playwright script, which is kind of, I think it's a wrapper around Puppeteer, or I don't know, maybe it's something completely different. But basically it's like Chrome driver. You're using a Chrome web browser, writing it in JavaScript, interacting with it to log into your website, and then, I don't know, visit all of your different client live views and, work around with it. And now you can test from the user standpoint, how is this performing? Are there any issues in any of my workflows? And this could run every hour after every pull request or whatever schedule you want, and help you like really ensure that uptime and quality that you're looking for. So if
Yeah,
I were
that's
you,
awesome.
I'd be looking at synthetic monitoring first, because you get a lot of bang for your buck out of that.
I'm gonna definitely have to check that out. I'm in a new world with this because I've always just built products from like, a very like niche perspective where, you only are building for one client. And then when you have all these other use cases, it kind of adds an extra layer.
For sure. Yeah, and you don't want your client calling you being like, "Hey, like this is broken," and you'd be like, "Oh, I had no idea." Like that's the worst feeling.
You want to say, I know, it's about to be fixed. Or you never have
Or
it be broken.
Or, hey, by the way, this thing was broken. We fixed it before you even knew about it, and we're letting you know out of transparency that there is a flow, just in case you got any reports from your customers.
That is much
before they ever
better.
Knew about it.
Yeah, a much better approach for sure. But yeah, Andrew Stewart, he's a great guy. I've had him on 2 times now, and it's kind of like he's great to have on to talk about anything, because he's been all in on the live view world. So whenever I need to learn something, because front end is not my strength, so whenever I want to learn something new, I just have Andrew come on.
Andrew is great. I'm always asking him live view questions as well, because he's, I think, really dialed into he kind of like really like loves live view from the front end perspective, which I think a lot of people using live view are coming at from the I don't want to write front end.
That's me, at least. I'm like a back end guy that only learned live view because my YouTube subscribers wanted me to teach it.
Nice.
Yeah.
Well, Andrew is a great human and great resource for all that kind of stuff. So
yeah, absolutely.
Definitely go bother him online.
Yeah, go bother him. If you ask me live view questions, like I understand like life cycle and like the majority of them, but the second you start asking me, tailwind classes and things, I hack my way through those. So it won't be a very good answer from me. But yeah, that's fun. I think we'd probably like have a good spot to actually I want to talk to open source contributions. I was going to say we could wrap this up, but open source is an interesting subject because I feel like a lot of people don't know where to start, or they're scared to get started. And from your perspective, do you contribute to open source projects?
Yes. I'm actually going to put myself in my shoes like 10 years ago, where I was asking the same question, which was like, I want to be involved in open source because it just felt cool. Like, it's like, oh, I'm going to work on something that other people use. And, it's very visible in that way. And I get to interact with people all over the world. Like, that sounds really interesting. I want to do that. Where do I start? And so I remember being in college and trying to contribute to this project called Hackety Hack, which was in Ruby. And funny enough, called back to the Rust book. The author of the Rust book was Steve Klabnik, was the creator of Hackety Hack. Didn't end up contributing anything, but I remember in my head as like that was like the first open source project I tried to get involved with. And then over the years, I kind of had this same stumble of like, okay, I started using JavaScript and Node.js, but it kind of seemed like too intimidating to interact with any of the open source projects. I was at Bloomberg around this time. We ended up open sourcing a early single page app framework called Bloomberg Brisket. And so I like had some very small features to that, but it was kind of an interesting experience to see like what open sourcing can do and kind of getting community participation. But it really wasn't until Elixir where I started to really get involved with open source, and it took a few years really to get involved. I would say for anyone who wants to get involved with open source, the best place is like use things. and see where there's gaps in documentation or things that just like don't make sense to you. And once they click, like go and make that small PR that updates documentation. That's just a great way to get started. And I do this all the time. Like if I notice a grammar issue or typing issue, or just like things could be a little bit clearer, I make these kinds of PRs all the time to Elixir projects in particular. My first like really fun Elixir related PR that I can remember was the Elixir XDoc. You know how you have the sidebar and like there's that drop down where you could see like all the section heads of like the page. Mm-hmm. So that was my first contribution to Elixir, was like adding that little thing. Nice. And I remember before that, like in live view, it was like kind of so hard to like find out like what I was looking for on the page. And then like that problem just drove me crazy. And so I was like, oh, I'm going to go fix this, and got some help from Wojtek Mach on kind of how to even approach it in XDoc. And it was just like so rewarding to implement that feature and then like see it now like everywhere, like every project uses that, which is so cool. And I think the way that you kind of like find these opportunities to participate in open source is by using software, seeing kind of like, I would like this for myself, and then going out and doing it. Since then, I've open sourced a bunch of software. At Milk Road, we open sourced a timescale DB wrapper, which kind of has sputtered and hasn't had a lot of interest, so I haven't been super motivated to keep working on it. We have a Lua wrapper that we're using at TV Labs that wraps LueURL, which is, I think, a whole other live stream that we could talk about. And if you're interested, come to Codebeam EU, where I'll be talking with Robert Verding about it. But I don't know, coming back to open source, there's just so many different ways to participate, and especially in Elixir, where it's a small community and projects really need help. Kind of sending PRs, participating in issue comments, asking where you can help. There's so many opportunities to get involved, and I think that the help is really appreciated, and it really helps push the community forward. So for whoever is like kind of looking where I don't know where to get started, the place is there's so many places. Look for the smaller projects. Don't try and jump right into Phoenix and LiveView. Those probably have the most eyes and the most competition. Go for the smaller projects that you're working on, or like even like something like ESBuild, which is a topic that came up today. Like go in there and find like gaps in documentation and send a PR. They're always appreciated.
Yeah, I was just using ESBuild to compile and build JavaScript for each of my custom domains that I'm building in my platform, and I learned a lot right there. But you learn a lot reading other people's code too. So
oh my God, yeah.
Just diving into open source code, you'll probably learn quite a bit. And then when you contribute, even if your PR gets rejected, hopefully you get like at least a constructive rejection, right? And you'll probably learn a lot in that process too.
For sure. It's kind of a superpower. Like once you get the hang of like, all right, I know how to contribute now, like being able to modify other libraries and add features and even depend on your fork of it is something that I've done many times, where it's like, I need this feature and I need it today. I don't want to just send an issue and like hope that someone's going to fix it. I'm going to fix it. I'll send a PR. And while I'm waiting for it to be incorporated, I'll depend on my own fork. That's a superpower, to be able to change your dependencies. But I think the thing that you said about, reading the source code and learning from it, that's something that really compounds over time, where, okay, I don't really understand how this works. I'm going to look, below the API and a level deeper, and you build this like much stronger understanding of the software, and it allows you to be a much more effective developer.
Whenever I read someone else's code, it still happens to me every time I do. I'm like, wow, I'm a horrible programmer. Like I have so much to learn, but like just having that realization, you just learned so much. Even if it's just like how you structure your modules or whatever you may be doing.
I'm feeling that really hard right now with I'm debugging a deadlock issue in Rust, and I'm doing exactly what we're talking about. Like I'm looking at the source code that I'm depending on, and I'm like, I know nothing. I know absolutely nothing.
Yeah, I don't know how many times I've opened up like source code to another project that I was just curious how it worked. And I'll look at it and be like, I don't know what's going on.
Oh my God. Yeah.
And then the more you do that though, and when you start actually breaking it down and you figure it out, it's a pretty awesome experience.
It hurts that when you first look in, it can be very overwhelming, and being like, I just don't know. I don't know how I'm ever gonna learn this, but you do. Like, I think the best thing to keep in mind is like, don't just stare at the code and like hope that you're gonna understand it. Like, pull it down locally and make some changes to it. Just like tweak it and, put in some log statements and try and like interact with it rather than just stare at it.
Yeah.
And that's kind of really where you kind of go from this is scary to, oh, actually this does make more sense than I initially thought.
Yeah, and I kind of like to think of like when you throw log statements in things, you're kind of just dissecting it, right? You want to see what's happening to whatever data is passing through a particular function or whatever it may be. But you're like dissecting a function you don't understand, and you can see what's happening to it in real time.
For sure.
I need to be a contributor to open source. I don't do it often, and I always tell myself that I should do it. But I do always dive into source code, because I think that's like definitely where I've learned the most, is reading other people's code base.
I would agree. I think I learned the most from reading really well written software.
Yeah, I had to build
Elixir source code is a great thing to do.
That is too. I had to build a very like simple game server for a client, and I was like, I have never built a game server. Like I understand the overall concept, right? And I knew I was going to use gen servers for particular things, and I found, well, one Wout, he made the live Svelte. He shared one of his projects. Yeah, he shared one of his projects with me. And that was one of those moments where I was looking at his game server and I was like, I'm an idiot. I don't know what I'm doing. And then I also found another game server on GitHub, and just looking at other people's code, it helped me build my game server. But that's awesome. Yeah, Wout's an awesome guy. I had him on here, and I don't know anything about Svelte, but super knowledgeable, super patient with me too, and answered all my dumb questions. So it was pretty cool.
Well, I'll have to ask him some dumb questions. We actually just incorporated that into our code base this week, actually. We're building a no-code tool for automating TVs, and a lot of this involves very client-heavy interaction. So it made sense to kind of dip our toes outside of LiveView into something more JavaScripty. So Live Svelte has been a game changer for this so far.
Yeah, I bet. That's awesome. Very cool. Super nice guy. Yeah, just reach out to him. I'm sure he'd be happy to help.
Awesome.
Yeah. Well, Dave, thank you so much for doing this with me. It was a lot of fun. And I think we were kind of all over the place, but I think it was a lot of awesome subjects.
Well, I had fun. Hopefully it was coherent. Thank you for having me on. It was a lot of fun.
No, it was a lot of fun, and I'll have to have you back on, and we can talk about so many other things. I feel like the list of subjects you were ready to go on, we could have hours and hours of conversations. So
cool. We'll love to chat again.
Yeah, I loved hearing about TV Labs as well. Sounds like a really cool project, or company, I should say, because you got a big thing happening there, and yeah, I'd love to hear more about it and maybe see it in person someday. See the farm. No, I forgot. What did you call it?
The compute cluster.
The compute cluster. I want to see that.
Awesome. Well, we'd love to give you a tour.
Awesome. And for everyone that tuned in, thank you so much for watching. I have all of Dave's contact info in the description below. Definitely follow him on Twitter and check out his blog. And I will see you guys later, and have a great weekend. Testing.